Okay, so today I'm going to be talking about a very cool trick that I learned in C, which is creating a defer macro. Now, if you used languages like Golang, for example, you might have seen something like this. So here I've just got a simple program which will open up a file or rather create a file. And then if you have sort of error, if you're trying to create the file like exists or something, then we just run the panic function, which will just terminate the program and print out an error message from the error, or else we just print out we successfully opened the file, right? So it's pretty simple. Now let's say I've got some more code down here. So I've got a byte array, which is basically just taking that string literal and divvying up into individual characters and storing that in an array. And I can do something here like file.write, which will just write all that data in the array into the file. Now something that I have to do is close this file handle, because if another process tries to access the file handle while we're still using it, it won't be able to, and there's a bunch of like other reasons that we need to close the file handle. So how do we do that? Well, in Go you can run the file.close function, and that will just close the file handle. Now if I've got a lot of code, for example I've got the three dots down there, that's symbolizing some more code, I might forget to call file.close, and because of that I might have some unexpected behavior when I try to access the file again. So Go provides a very useful feature called defer. What defer will do is that it will take the code after the defer keyword, so in this case file.close, and it will automatically run that code at the end of the scope, wherever that might be. So to give a more sophisticated example, let's say I've got an exit call right there. So I've got exit 0. What that function will do is just terminate the program at that point where I call exit, and then it will just return a status of 0. Now let's say I've got this exit function, or rather this call to the exit function, and I've got some more code underneath it. Now if you think about this logically, as soon as the exit functions run, the whole program is terminated, right? So what would defer do in this case? Because if we think about it running at the end of the closed parenthesis, or the closed curly bracket, it won't run the code when we want it to. So Go recognizes that certain keywords and functions will terminate the program early, and that actually represents the end of the scope. So Go will automatically recognize that and run the function before exit is called, right? That's pretty cool. However, why would you want to use this? Because if you think about it like this, it's like, yeah, it's kind of cool, but it's not that big of a feature. Well, let's look at a more modern language like Zig, which also has a defer feature. So here I'm going to walk you through how this little example works. I'm getting a general purpose allocator, and then I'm allocating a buffer on the heap, right? So this buffer has enough space to store 256 ASCII characters, and then I've created this hello world string literal, and then I'm using the copy forwards command just to copy that string into the string buffer. So I'm just storing that string in the buffer, right? Now let's say I have to, after I use this or do whatever one with the string buffer, I have to free the memory, right? I have to give it back to the heap, otherwise we have a memory leak. Now in languages like C, this is quite annoying because you have to make sure they remember to call the code to, you have to remember to call free after you finish using the memory, otherwise you have the leak, and sometimes because of how the codes run, it doesn't actually call the free function because of some if statements or whatever. So it's a very error prone procedure. Well, in Zig, they've got a defer statement. So here I can do allocator.destroy string buffer, and whenever the function, whenever like we're out of this current scope, it will automatically just destroy or rather just free the string buffer for us. We don't have to worry about that. Now, if you guys have used a language like C++, there's actually a lot similar to a feature there called a smart pointer. So a smart pointer is basically just a pointer to memory in the heap, and it's automatically freed by the compiler at the end of the current scope. So that kind of feature of automatically freeing memory is called RAII, and you can see here we've implemented a very simple version of RAII. Of course not the complete version, but we have this kind of idea of the memory being freed automatically for us at the end of the scope. So how could we do this in a language like C? Well, the GCC compiler specifically has a compiler extension called cleanup, and this is how it looks like. It might not make sense to you, but what you need to know is that if I have a variable and I give it this extension, or rather I add this line of code to mark it is using the cleanup extension, then as soon as that variable goes out of scope, this cleanup function automatically is called. So if a code is in the cleanup function, it's going to be called automatically for us. So to show you guys how this looks like in a basic example, I've created an int val variable and I set it to 5, right? And then I created an exit function which takes in a pointer to an integer, and in the cleanup procedure I pass this in as a function. So then I run some more code called print. I run printf to print out hello world. So if you run this code, what will actually happen is it will print out hello world first, and then it will find the return statement. Now GCC knows that the return statement marks the end of the scope, so then it will go and it will check on val's cleanup procedure, which has been allocated, which we have specified for it, and it will just pass in the value of val into the exit function as a pointer, and then we can just print it out right there, right? And now that I realize it, we should also dereference that value variable in the second line. That's a little bit of a mistake there, but I hope you guys understand the overall concept of how we're going to implement this in C, because the way we're going to do it is using this cleanup extension. Now if you're wondering about how we can do this on Clang and MSVC, there should be an equivalent function for it, I'm pretty sure, so you can go and Google that. If I do find some examples of it, I'll put a link to the description to show you guys what the equivalent code would be on MSVC or Clang. So here I've got a very simple hello world program, and to show you guys how we'd actually structure this macro, I'm going to write down a basic example of how it would work. So what I want to be able to do is do something like defer, then open up a scope or like squiggly brackets, and then write whatever code I want here. So like printf hello world, for example, right? And then at the end of this function, let's say I do printf hello, it should do something like print hello first, and then it will run this defer statement, then print hello world, right? So how can I do that? Well, the way this macro is going to look like is we're going to first have a function declaration, so a unique name for a function we're going to call. So let's say, I don't know, void return defer func. So I'm taking an int pointer because we're just passing it into it, and we're just declaring this function exists, right? And then we're going to have something like int defer val attribute cleanup, and then we pass in defer func right here, and then we just define defer func down here. We just add whatever code we want. So the macro will have these lines, right? So I'll have these 3 lines, and then whenever we actually call the macro like this, right, this statement right here will automatically just be put here, so we'll just finish off this defer func. So there's a kind of, if you're looking at this right now, this should probably make sense. However, if you want this code, just to show you guys to see if it works, let's see, we get an error. So defer func follows non-static declaration. You get some weird errors there. So what does that actually mean? So by default, you can't have nested functions inside of C. However, there is a trick you can use to get around it, which is just put auto in front of the function names. I forgot to put the semicolon right there. So if I do something like printf first, let's say second, right, I run this code first, then it will run the code inside this defer function. So that's basically how it works. If you're wondering why auto fixes those errors before, to be honest, I'm not fully sure why it actually does that either, because it should not technically allow this code to compile, because auto is implicitly implied whenever you create some kind of like function like this inside of a function. Or if I do something like int x equal to 200, it automatically gives it a scope of auto, and auto just means that this function lives for the lifetime of this scope, right? So I'm not really sure how this works. I think it's more like a bug in GCC. I'm not fully sure. So if you guys know why this works, you can just write down in the comments, but we just need to understand that this fixes the errors that we had before. So let's turn this thing into a macro. So I'll say something like define defer, right? Then I pass in func name. What is it? Actually, I say defer func name, defer var name, right? I'll say defer func name, then defer var name, and then I'll do the same right here. Then I also remove the scope because we're gonna fill it out ourselves. Then also add these backslashes, right? Okay. Now the thing is, if you've got multiple defer statements, I've got something like defer in text. I don't know, right? I'm just gonna create a bunch of these. So you get the idea, right? If I've got multiple defer statements and I try to use the same function name and same variable name, I'll get errors because we're redefining the same functions of variables, right? So what we have to do is find a way to generate a new function and variable name every single time we call this defer macro. How can we do that? Well, in C we have this, or rather in GCC, I'm not sure if this is in the C specification, but we have this macro, or not macro, we have this, let's say thing. We have this macro variable or compiler extension, whatever you call it, counter. Basically, whenever we call counter, it automatically increments a new value and just substitutes it there. So if I do something like thing is printf %d, and then I do something like counter, right? And then let's say I print it out. So I do something like thing 3 times. As you can see, every single time I call counter, it just auto increments. So it starts at 0 and goes 1, 2, 3, 4, 5. It just continuously goes higher and higher, right? So what we can do is something cool, like let's say I'm gonna print strings. So I can do something like defer func, and then if I do 2 of these hashtags, it just takes this identifier right here and takes the value from counter and just joins them together into one single thing identifier. So I can say defer func, then can something like defer var, right? If I do that. Okay, so I think I missed adding the 2 underscores right here, and we still get these errors. So basically, you might be thinking, why is this not working? And this is just because of macro indirection. We have to call this macro with some other macros in order for this to work. So what we're going to do instead here is we're just going to take this code right here, remove it. I'll create a macro here called defer1, right? Let's call it defer1. That's going to take in n, and it's going to just pass in this n right here, right? Then if I try calling defer1 like this, and then I just pass in, I don't know, counter. So this was just taking the same value of counter and append them for both the defer function, the function name, and the variable name. So if I call that right now, I'll still get errors because there's redeclaration of defined var character. So what I can instead just do here is add another macro here called defer2. That takes an n. Let's call this defer1 with n. Then I just call defer2 instead, right? And this will magically fix the issue. So if you just do that, now if we run it, so there's hello world, then 4th, 3rd, 2nd, 1st. So this is important. The last defer statement is going to be run first when the scope ends, and so like it's in reversed order, as you might think. So let's say I've got this simple example here. Let's say I've got a scope inside a scope. So I've got, I don't know, defer printf finish the inside scope, right? Then do something here like printf inside the scope. So if I run this, what's going to happen is we're going to have inside the scope being printed first. Then we finish this scope, so this defer statement is going to be local to the scope. So we're going to find that the scope's being finished. So he runs finish the inside scope, then he prints hello world, then he runs this defer statement, right? So we can have defer statements. So the defer statement basically is local to the scope. Whenever the scope it's been declared in ends, it runs the code is being given. So one example how we could do this is, let's say I do something like char pointer string on heap is equal to malloc size of char. Actually, I don't even need that. Let's see. I can do, let's say 1000, right? And then I have a bunch of code in here which just does a lot of stuff. Then at the end I have to do something like free string on heap, right? But if I got a lot of nested function calls, I might exit from a function which terminates the program or something. Then if I get to, sorry, not terminates the program, but I might accidentally miss this call if I have it somewhere inside like nested functions. So I can just do here is do something like defer free string on heap, right? And then I can do something like printf string on heap. Let's copy the string into there. I have to include string.h for it to work. There we go, then it's automatically freed for us. And if you guys actually want to see the end result of it trying to free it, let's just do this. So do something like save temps, and what it should do if I now check out, okay, there we go. That's the assembly, wrong one. So I think it's main.i. Yeah, this is the right one. So if you just go down, let's see. String on heap, right? So it runs this defer. So I created this string on the heap, then the macro just runs here, so creates func0, right? Then the var attribute, then it just runs the func0 one. So let's say I got another defer statement, like, I don't know. Right, so now if I go back to this function, I've got the second defer and it incremented the counter, so I've got a unique function and variable name here. So if you guys are interested where I learned this from, is from this Jensen Goosted's blog. He kind of showed you guys, he kind of explained the whole idea behind it, and I just modified it so it supports C11. But the general idea is very similar to this one, and then it has this defer statement with C++, which also uses lambdas. So I hope you guys enjoyed this video. I hope it's been enjoyable, and if you have any questions about how it works, please leave a comment. I'll be happy to explain it. And yeah, I made some videos about Arenas before, which you might enjoy if you watch this one. So thank you for watching. I'll see you guys later. Bye.